Safety is a critical concern in modern systems, with most requiring safety monitoring to protect the user during operation. Engineers typically have two options for implementing fault management features and monitoring: a discrete component approach or MCU-based approach. The discrete component approach for safety monitoring, while simpler and often lower cost, lacks intelligence and consumes a large board area. Meanwhile, an MCU-based approach adds flexibility and intelligence, but the cost of software development, runtime maintenance, and certification makes it more expensive. Texas Instruments' Smart Digital to Analog Converter and Analog Front End integrates the best of both approaches, simple and independent from software, while also highly integrated and logic capable. Let's dive in and explore more. Smart DACs and AFEs, such as DAC 63204, integrate numerous tools to help with fault management. For this example, we will show you how to use the DAC 63204 as a programmable comparator. Each channel of the DAC 63204 can be independently programmed as a comparator with a configurable hysteresis or window comparator, and the output of each could be used as a fault flag or as a latching flag. All of the configurations could be stored in a non-volatile memory for software-free operation. Let's take a closer look at the demo itself. For this demo, we will showcase 4 comparator channels. There are 2 inputs to the device, a GPIO pin that is connected to this button, and the 4 analog inputs to the comparators, all tied together to this potentiometer. The GPI is used to toggle between 2 different programmable threshold voltages as indicated in this table on the demo. We will start with margin high setting, where the threshold voltage of a comparator 0 is 4.5 volts, and so on. The LEDs indicate the state of the comparator output. It is on when output is high and off when the comparator output is low. As we turn the potentiometer to increase the input voltage, each LED will turn on as we achieve input higher than the threshold voltage for each comparator. And now, the same but for margin low threshold voltages. This is one example of how Smart DAC could be used for fault monitoring and management. Explore more in other videos, and for more information on Smart DACs, please refer to links below or post your questions on our E2E forum. Thank you for watching.